So this spool of filament was full when I started. And I've been printing pretty much non-stop since Friday night. And it is now afternoon Sunday. So what I'm working on is an electronic board game. Kind of like a pinball machine, technically. Gameplay, it's a little bit like pinball. It's very scaled down because I have design constraints. I'm working on this for an engineering contest, competition, put on by our school, and I have size design constraints. That's really my main constraint here, size. I'm kind of butting against that already. So I'm actually going to pause this because I don't have one of the parts I need to show you. It's over on the other side of the room, and I'm not going to walk over there with this running. Be back in a second. Okay, here it is. So the way this works, this game, is there's a game board, which is a piece of clear acrylic, which is also on the other side of the room, but it's really too big to fit on this rather small work table. Well, actually, I'm still going to grab more parts. 1 second. Okay. So there's these chutes, these holes, they go through a hole in the acrylic, that allow you to position them. And then you take this, which is, a metal, marble, or a metal ball, and you put it through the chute. What can I put this through? Put it through my spool of wire. There we go. Yes, I know my workbench is a giant mess right now. I've been very busy. This engineering contest came up very last minute. So I just dropped everything and just have spent an exorbitant amount of time preparing for this. So you put this through the chute, and it comes out the other end. So these were modeled by me in 123D. These were the first two things I printed. And then there's all of these. So it goes through the chute, it goes across the game board, there's holes in the game board, and the idea is to drop it through the hole, it drops onto this, and it slides down these two metal screws, into like a collection bin. And when it slides down these are going to be wired up to an Arduino to these analog pins, which I'm just using as digital inputs because I'm pretty much using all of the digital bins, and even then I'm using two Arduinos. The proper way to do this would be using shift registers, but I don't have any shift registers and I don't have enough time to order them. And because I don't have any shift registers, you can infer from that I've never used them before, and even though I don't believe they are that hard to use, I really don't feel like learning something new when I have to have this done so last minute. So I would rather just do something that I know works, that I've done 1,000 times before. So we're just going to use two Arduinos to get enough pins. It's fine. It's really not ideal, but it's fine. It's not ideal because its Arduinos are relatively expensive. So using two of them is just really inefficient and pointless, but hey, it's a DIY project, and the Arduinos are actually a decently small portion of the cost, because I'm probably going to use basically that whole spool of filament by the end, so that's like $25 worth of plastic right there. Basically, this project is becoming quite expensive, which was not my original goal, but it's fine. Everything's fine. I'm like kind of at my wit's end. I haven't slept much the last few days. I've been waking up really early because I'm really trying to get this all done in time. Basically, so what it works is this goes, and this is a button. Okay, great. So then the Arduino gets that button inputs, and it has these light boxes, which are going to be under the acrylic game board. The game board's acrylic, if I haven't mentioned that. And it's going to be fogged acrylic. Right now it's just clear, but I'm going to fog it. And then these light up. So I'm wiring all of these up. These are pin headers, but they're 90-degree pin headers, so I can stack the Arduinos. These are pull-up resistors for the buttons that are just kind of thrown about like these. These are current limiting resistors for the LEDs. So yeah, there's these LED boxes. So it goes green, yellow, red, depending on how much your partner, not your partner, your competitor has done. So for each hole, because there's going to be 3 of these, and there's going to be a 4th hole as well that's going to be hooked up to this, and I'll explain that later. But for each hole, you have 3 lives. 1, 2, 3. And that's actually configurable in software. So if you wanted to have holes that only had 1 or 2 lives, or if you wanted all of the holes that only have 1 or 2 lives, you could configure that all in software. And I'm going to open source the Arduino code for this and probably upload all of these CAD files if anyone wanted to build this. I don't know, or improve upon it, because I don't know how fun it's going to actually be to play. But I consider this to be fairly technically impressive, especially given the fact that I have very little time to build it. Yeah, I don't know what else there is to... Oh yes, I need to explain this. Okay, so this is for the 4th hole. Yeah, and this is just a common ground lead. It's going from the ground on the Arduino, and it's going to here, along a bus bar to there, along a bus bar to there, along a bus bar to here. So this is the 4th one, and this is going to be on your opponent's side. So if you score on your opponent, on here, what happens is you don't get a point, but your opponent loses a point. So this one's going to be the closest hole to you, the easiest one to score in. And the reason for that is, in order to win, you have to light up all of your opponent's lights. But if your opponent is close to winning or something, you can take the easy shot and get another chance. Otherwise, you have to take the harder shots. So that's the idea behind this. Yeah, so it's the game board's going to be laid out somewhat like this, maybe something kind of, and the Arduino's just going to be under there somewhere thrown around. I'm probably going to power it all with this battery. This is a protected cell. It's from a really cheap Chinese tablet that broke after like a month and was a giant waste of money. But I wanted to buy to hack around with, because I was hoping that, well actually, originally I was hoping it would be a decent tablet. And then I read a bunch of stuff online that it probably wouldn't be a decent tablet, and I'm like, well, even if it isn't a decent tablet, I can probably get a refund and then just have it to hack around with. And I got a lot of my money back, but I didn't get all of my money back. And then I was like, oh, well, I got enough of my money back. It's fine just to hack around with. And then it broke. So, yeah, but I, at least I got the battery out of it. So we're going to be using that for this project because it's really thin, so I can easily fit it under the board, even with all of this other junk under there. And it's protected, which is good. And I have this charge IC here from AliExpress that we're going to be using. And I probably also need a boost converter because I know the Arduino has its own built-in regulators, but I would rather just feed it 5 volts just to be safe. Yeah, I might just use a power bank IC, but I'm worried about that shutting off because the Arduino draws so little current. But we'll figure all of that out eventually. Yeah, so this is just one half of it because this is one of the Arduinos. So this whole thing is going to be done on the other side, and again, the buttons aren't even wired up yet. In fact, I only have a few of these made. I'm printing the rest of them right now. Yeah, this is a very ambitious project. And hopefully it turns out well, because that would be cool. Yeah. You can tell I'm not especially worried about these LED light boxes looking good. These are all individual, and then I put them together. I don't know, I maybe should print them together. Maybe I'll print the ones for the other side together, because those aren't even printed yet. But these are going to be under the acrylic, so no one's really going to see them. Let me pause the camera, and then I'll move over to the acrylic game board, because we can look at that now. That's probably the last little bit of stuff to look at. So this is the acrylic game board. You can see I drilled one hole, and I drilled this hole here, and I cracked it. This is a hole for the, what's it called, the chutes. And the reason I stopped drilling holes was after I cracked this, I'm like, I'm just gonna laser cut them. Because this is a competition for school, and the school has not laser cutters. The school has a laser cutter. So I will just laser cut this there. This is an 11.5 by 11.5 sheet of clear acrylic. And you can see these holes, and this lines up under the holes, and it's eventually going to be held in place. Here's a tiny bit of the collection chute, maybe. This is, of course, going to be a long, continuous thing, but for now we just have this little one, just to test it with. So, you know, you drop this down there, and it goes like that, and I just broke everything. It's fine. I just knocked over one of the supports, because the supports are not connected yet, because I'm not going to connect these, because I need to take out the acrylic to be able to laser cut it and sand it to fog it. I'm going to pause it while I put it all back together. Okay, there we go. It's all back together now. Yeah, so this is just the basics of it. Depending on how stuff turns out, I may end up putting some obstacles on the board. We may end up fine-tuning it. We may end up putting, like, a backboard here. I'm probably going to need to put a backboard here. I didn't necessarily want to do that. You can see we have this edge board here. And yes, this print didn't complete. I just canceled it because it was taking too long. And frankly, this edge board is high enough already. I'm probably going to cover this with some sort of paper or plastic for aesthetic reasons anyways. So it doesn't really matter. You can see that this chute looks terrible because of supports. But that's fine. Not much I can do about that. Yeah. Again, this is the second Arduino. You can see it has the pin headers on it. I haven't even started building the assembly for it yet. And you can see I do have a decent amount of room under here. But again, there's going to be a lot of stuff under here with all the light boxes and 2 Arduinos, and all the wiring and a battery pack and boost converter and charge controller. I'm really running up pretty tight against the size limits here. So hopefully we'll make this work. Yeah. That is all. You see, originally this was just gonna be, this was gonna be bigger and even more ambitious probably, but that was not a good idea given how much time I had and the size limits. Yeah, it's fine.